All right, guys, here we go with page 4 of the notes. We just have one example today to look at together, and then you'll have some practice to look at. So we want to graph 2 cosecant 3 times, in parentheses, x minus pi over 6 plus 1. Okay? And I really want to make, let's use this lighter blue. I want to make 2 cycles. Okay, and this is really the same thing as f of x is equal to 2 times 1 over sine 3x minus pi over 6, parentheses, plus 1. All right, so I want to think about the sine graph, right? General characteristics of this. So the sine graph starts at 0. That means this graph, the cosecant graph, wherever it starts, it's going to have a vertical asymptote. Okay, so I'm going to list out, just like before, some important properties. So PS, the phase shift, that in this case is pi over 6 to the right. Okay, the center line now, the center line of this graph is going to be at 1, okay? So that's going to be at y equals 1. The period is equal to 2 pi over 3, right? So we have this 3 multiplying x. That's going to affect the period by compressing the graph horizontally by a factor of 3. So the period used to be 2 pi, now it's 2 pi over 3. And then one other thing, the amplitude, I'm going to list it because it's really the amplitude of sine. It's going to affect sort of how high and low the cosecant graph goes. So I'm going to put, even though we said there isn't really an amplitude, so I'm going to put like a star here. I'm just going to say it's equal to 2. All right? Let's make some axes. I'm going to make the axes, I guess, in green. And I should be careful. I'm not going to make axes. I'm going to make the center line and the phase shift. Okay, so this is the line x equals pi over 6. And this is the line y equals 1. Okay. So I know that the sine graph starts at 0, so that means in this case at pi over 6 we're going to start with a vertical asymptote. Okay, so I'll make that, I'm going to make that red. I'm going to make that red. Okay, so this is a vertical asymptote. And I know the period's 2 pi over 3, so there's going to be another vertical asymptote there, and I'm just going to arbitrarily let's do this. 2 pi over 3 over 4 is equal to 2 pi over 12, which is pi over 6. Okay, so I'm going to make every one of these tick marks here pi over 6. Let's see what I mean in a second. So we'll go pi over 6, pi over 6, pi over 6, pi over 6. Okay, so that means right here, this is 2 pi over 6, which is pi over 3. This is pi over 2. You know what? I'm going to make it a little bit more spread out. Sorry, guys. Because we're only going to do 2 cycles. So let's go 4 for each. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so pi over 6, 2 pi over 6, which is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, which is 2 pi over 3. And 5 pi over 6. So now my total distance from where I'm starting to where I'm finishing, that's 4 pi over 6, which is the same as 2 pi over 3. So That's going to be one full cycle. That means that I've got a vertical asymptote here, okay, and halfway between those, I've also got a vertical asymptote. Now the sine graph, right, the sine graph normally starts at 0 and goes up. So in this case, this thing's going to go up 2 units. So from 1 up 2 is 3, right? So let's go back to green. I'm going to go up. That's 1. That's 2. So that is y equals 3. All right, so this is 2. This is 3. And the sine graph would touch. Need another color here. We'll do black. Would touch right there. Okay, it goes down to. So those are my guidelines. I can make this if I wanted. Dotted, just to show that this is going to guide the cosecant graph. Okay, and it's going to continue to go like that. So when I make the actual cosecant graph now, I'll take blue. It's going to touch this point. And oh shoot. It's going to touch this point. It's going to go up towards those asymptotes. Okay, this part's going to go down towards those asymptotes. So that's one full cycle. And now I think, let's see if I can do this. Can I erase kind of cleanly this? Yeah, kind of. That 2's getting in the way. I don't want that point there either. So the blue here is what I want. That's the actual graph of cosecant. All right, I'm gonna let it go. Pen, let's do this green. Let's fill this in a little bit. Okay, good enough. Not good enough. There we go. All right, we got to do the same thing on the other side, and then we're set. So what I did 4, right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so by pi over 6. So this is 0 now. This is negative pi over 6. This is negative pi over 3. And this is negative pi over 2. So again, if I check from pi over 6 to negative pi over 2, from here to here, well, that's a distance of negative 4 pi over 6, or distance of 4 pi over 6, which is the same as 2 pi over 3. Great. So let's put these asymptotes in here. So there's going to be one here. There's going to be one halfway between those two asymptotes here. And then I can use the periodic nature. So I say this point here, well, that's going to be repeated over there. And this point down here, that's going to be repeated over here. Okay? And what we're going to be looking for is we want to be sure that we understand what these points are. So this right here, yeah, it's pretty clear. I can understand that's negative pi over 3, 3. This point, well, it's 0. I don't know what the y value is, so I better label that. So we're going to go down 2. So if that's 1, this is 0, and this is negative 1. Okay? And yeah, that's the graph, guys. One more thing I'm going to do, I like to do this sometimes when we can actually put the real true axes in. So here's x equals 0, so that's the y-axis right there. And the x-axis is going to be right here. Okay. So, really, this was our starting point, right? Here's the origin, 0, 0. So we went over some distance and up, right? And that's because of this phase shift right and this vertical shift up. All right. One more thing. Just bothering me. I want to get rid of that. So that's good enough. Hope that makes sense.